I just want to do a short video to go over how to do this when it is a function continuous worksheet that you're going to have for homework. So it starts off asking about this graph, and it asks you to complete the table below. So let's just look at the table here, and we can see, we're just going to fill this in really quickly. And so at x equals -2, our limit from the left is going to be positive infinity. Our limit from the right is going to be positive infinity. But f of c is undefined because there's no dot on the line there. At x equals 1, we can see that the limit from the left is 1. The limit from the right is 1. But f of c here, undefined, because we have an open circle there. At x equals 2, our limit from the left goes to this point right here, which has a y value of 2. Our limit from the right goes to this point right here, which has a y value of 4. And f of c is going to be where your dark circle is, where your closed-in circle is, and that's at 2 here. And then f of 4, we can see that our limit from the left is going to equal 2. Our limit from the right is going to equal 2. But when we're looking for f of 4, they have to look at the closed-in circle down here, and that is 1. So basically this sort of has you look at all of the reasons why a function might be discontinuous. If we look at the directions for the next chart here, it tells us we're going to use the information from the table to indicate the reason or reasons for the discontinuity at each x equals c by placing a check mark in every column that applies in the following table. Note that a check mark in either column 1 or column 2 will necessarily result in a check mark for column 3, because if one of the values is not a finite number, then it is not possible for another value to equal that number. So here they're saying that the limit is not a finite number, probably because they're hesitant to use does not exist, because students might think that a limit that is an infinity does exist, although we've talked about that those limits technically do not exist. So if we look at x equals -2, if the limit as x approaches c is not a finite number, then if we look here, that limit from the left and the right, they do equal each other, but it's not a finite number. So we're going to put a check mark right here. And then f of c is not a finite number. That is true because this is undefined. And so we have check marks in column 1 and 2. 3 has to have a check mark as well. If we look at example, or at x equals 1, we do have a limit that exists because our limit from the left and the right both equal 1. So we're not going to put a check mark here. We do have a limit. However, f of c is not a finite number. F of c is undefined. So we have a check mark in column 2. So since 1 cannot equal undefined, we must put a check mark in column 3. For the next one, our limit does not exist because at x equals 2, our limit from the left is 2 and our limit from the right is 4. So our limit does not exist. However, f of c does exist. You do have a closed-in circle here. But because the limit does not exist, then column 3 cannot be true either. The limit cannot equal the value of the function. For the last one, our limit does exist at x equals 4 because our limit from the left and the limit from the right both equal 2. And f of c also exists. It is a finite number. It is 1. However, 2 does not equal 1, so our check mark only goes in column 3. So all of these are cases where you have discontinuities in the graph. All of them are for different reasons. Okay? So once you go through that exercise, you are going to be asked some questions about the intermediate value theorem. So the first thing you must always check for intermediate value theorem is continuity. So you're going to use that information that we just looked at to help you whenever you're doing these problems. Now, I've picked the first one to look at because it uses a table, which we had not looked at in the notes. Also, here, so we've got, this problem takes a little of the work out for us because it says continuous function g of x. So we are supposed to decide if IVT applies or does not apply, and why or why not. So I know already that g is continuous. And we want to say, therefore, there exists some r in the interval from 0 to 2 for which f of r equals 5. So if we're thinking here, we're looking just from 0 to 2. So really it doesn't matter what in the world we've got over here. That's just extra information. And we want to know if we have any y values, any, that really should be a g right there. This is a typo on this worksheet. Really, whether that g of r equals 5. And so we want to know if this y value has to be 5 anywhere. So we're going from 7 down to 3. So if we go from 7 down to 3 in a continuous function, we've got to cross 5 at some point. So in this case, intermediate value theorem, check the wrong one there. Intermediate value theorem does apply. So this is going to be a case where it applies. So we are going to have to start with g of x is continuous. And we also need to say that 5 falls between 7 and 3. But when we do that, we want to say not just 7, but g of 0. That tells us that's the end point right here at 0. G of 0 equals 7. Oh, I've messed up here because 3 is less than 7. So I really should write my 3 first. So I'm going to say instead g of 2 equals 3, because I know if I plug in 2 I get 3. That is less than 5, which is less than 7, which of course is our g of 2. So these are the conditions that you have to say. For these, I don't think you need to go through and say, therefore, there exists some r in the interval 0 to 2 for which this has happened. So you could say this right here if it was for your response question on the AP exam. But we can say that this applies because g of x is continuous and 5 falls between our g of 0 and our g of 2. Okay, so that's what you'll do for those problems. Whenever you get down here to the end, it's going to give you this table, and it's going to ask you several different questions about these things here. So read through those carefully. We will go over, especially this last part, in class on Tuesday.